All right, boys and girls, ladies and gentlemen, welcome back to another exciting edition of Math Notes. Today we're going to be talking about polynomials, and this is section 1.1.4. So what is a polynomial? That's the first thing we're answering. A polynomial expression in one variable is an expression that can be written as the sum or difference of terms in the form of any real number times x, or another variable, raised to a whole number. So a little quick example of that is any real number like 3x, raise that to the fourth power. That would fill in that same pattern there. So that would be a polynomial of fourth degree. So polynomials in one variable, often x, are usually arranged in powers of x, starting with the highest, going to the lowest as we go from left to right. The highest power of the variable in a polynomial in one variable is called the degree of the polynomial. So you're going to want to write that definition down. The highest power is called the degree of the polynomial. So in this example, this would be a fourth degree polynomial because it's x to the fourth power. The numbers that are multiplied by the variable in each term are called coefficients. So we've got coefficients and we've got exponents. So let's take a look at this. Let me straighten this out real fast so we can fit it all in. So another definition here, you're going to want to know that the numbers that are multiplied by the variable in each term are called the coefficients. So in that case, the 3 would be the coefficient. Okay, write those down. These descriptions also apply to functions defined by polynomial examples. Let's look at some examples below. So example number 1, 3x plus 5 is a polynomial of degree 1 with coefficients 3 and 5. That's because the power of x right there is x to the first power. Note that the last term 5 is called the constant term, but represents the expression 5 times x to the 0, and since x to the 0 is 1, 5 times 1 is just 5. The related linear function y equals 3x plus 5 is a polynomial function of degree 1. Again, because that degree is the highest exponential power there, which is just x to the first power. Example number 2, 7x to the fifth plus 2.5x to the third minus 1/2 x plus 5 is a polynomial of degree 5. Degree 5, 5. With coefficients of 7, 0, 2.5, 0, 1/2, negative 1/2, and 7. Example 3, a little trickier. We have 2 times x plus 2 times x plus 5 is a polynomial in factored form with degree 2. Now, when you're trying to figure out what the degree of a polynomial is when it's in factored form, you can multiply it all out and get the final general form of the equation, or standard form, which is 2x squared plus 14x plus 20. Or you can say to yourself, this is an x times another x, and when I get x times x, I'm going to get x squared. So I know that it's going to be degree 2, and I know that it's going to be some sort of parabola, because that's what degree 2 polynomials graph to. And the standard form has, okay, we have the coefficients here, and the related quadratic function f of x is equal to 2x squared plus 14x plus 20 is a polynomial function of degree 2. Yep, we said that already. We're good to go. So let's take a look at some examples on the next page, some little problems I want you to deal with. Take a look at these 3. What is the degree of each polynomial? Simplify each of these to verify your answer. So take a look at those 3 problems, guys, and get it done for tomorrow.